Hi hackers, we're back, and with me is Carlos Matallana from Hermez Network. And I see that Jeff Prestes is also joining us, and they are going to conduct a workshop and tell you more about how to build on Hermez. Hi, Carlos.
Hi, thank you all for being here. I'm going to perform a workshop and explain how to use Hermez.js, which is an SDK in order to interact with Hermez Network. I'm going to share my screen.
Yeah, so the stage is yours. Bye.
Thanks. Okay, can you see my screen?
Yes.
Okay, let me check. Okay, we'll press it again, sorry. This is the one. Okay, okay, let us start. And we're going to do 4 scripts with Hermez.js in order to learn how to use it. These 4 scripts will consist on setting the proper environment in order to use Hermez.js. The second one will be to create a wallet. The third one will be to make a deposit into the Hermez network. And the last one will be to do a layer 2 transfer, okay, in Hermez network. I assume here that you're a little bit familiar with Node.js, JavaScript, and NPM. In order to do the workshop, I already set up a few things previous to the workshop in order to save some time. As you can see here, I just import Pada and Ethers, which are common libraries used in Node.js. I also installed the NPM package of Hermez.js. You can find it here under the umbrella of Hermez Network. And also, since we are going to create some wallets and perform some deposits in Ethereum and perform some transfers, in layer 2, we need some private keys. So in order to load those private keys, we are going to use environment variables. So I created these environment files in order to load them. I will explain one by one those variables. The first one is the Ethereum node URL. You may have your own Ethereum node in your home. I think it's better that you have one, but in case that you don't have one, please go to Infura and get some Infura URL in order to interact with Ethereum. The next one would be the Ethereum private key. Okay, this is the Ethereum private key in order to load the Ethereum address and in order to create the wallet. We're going to define which token are we going to perform the deposit and transfer. As we will see later, there are several tokens that you can use in Hermez Network. And one of them is Ether. So we're going to use Ether. And here there are just some configurations regarding the amounts that we're going to deposit and we're going to transfer. And when we perform the layer 2 transfer, when you perform a transfer, normally there is the sender and the receiver, and here we configure the receiver. So these 6 variables would be needed in order to perform the following scripts that I'm going to make. Okay, first of all, the first thing to do when working with Hermez.js is to set up an environment, okay? In order to do that, the first thing is to load the environment variables, which is the Ethereum node URL, okay? After that, we're going to check which is the default environment, okay, for Hermez.js, okay. Here, as I said at the beginning, I import the Hermez.js package, and there is inside a section which is the environment, and you can get the current environment, okay. Okay, let's see what is inside this current environment. Okay. You can see here I just lock the Ethereum node, which is this. We're going to perform our actions in the testnet in Rinkeby. And the current environment, the default environment in Hermez.js, you can see there are some contract address for Hermez and then without the layer. Hermez is the main contract to interact in order to perform deposits. The without the layer, I'm not going into the details here, but it's in order to perform some exits for the Hermez network. And then we have three more variables, which is the base AP URL, batch explorer, and Etherscan. The default configuration are set by localhost and Etherscan. And what we want now is to switch the environment into the environment that we want, okay? And which environment do we want? Well, it does depend on the provider that we have, okay? Here we have the provider based on Rinkeby, and Rinkeby has a chain ID the chain ID of Rinkeby is 4, okay? The chain ID of mainnet is 1, the chain ID of Goerli is 5. So with just getting the chain ID from the provider and setting the environment with the chain ID, it's enough to set up the whole Hermez.js environment. Simple as that, okay? We can do that because inside Hermez.js, and I will show some code here, already has hard-coded all the necessary data in order to work in these chains, okay? In mainnet and Rinkeby, okay? We have the Explorer, we have the Etherscan URLs, the public base API, which is the coordinator URL, the contracts, and so on. Okay, so in order to check that we have correctly set up the environment, we're going to watch it. We're going to set the environment, okay, through the chain ID, and we're going to get again the current environment, okay, and we're going to check the change in the environment variables. Okay, we can see here the environment for chain ID, the environment for chain ID 4 has been set up in Hermez.js with the correct Hermez smart contract address, the withdrawal layer smart contract address, the coordinator URL, which is the base API URL, batch explorer, and Etherscan. Okay. At the very end, it's just about 3 lines of code to set up the environment that you are going to work. Okay. And I'm going to set up one more thing here. It's also important, which is the provider. Okay. In order to create wallet, in order to perform deposits, in order to perform some kind of action that needs an Ethereum node, you can set it manually, or you can set a global variable in Hermez.js, which would be the provider. Okay. This will save time afterwards in all the scripts, because you don't have to put again and again the provider if we just set it just once at the very beginning. So here I'm setting the provider with the one that I load from the environment variables. Okay, and this is how we set the environment in Hermez.js. Okay, Now, let's move forward and see how to create a wallet. Okay. At the very beginning of the script, I'm going to just copy paste the code that I used in the previous script. Okay. Just load some environment variables. In this case, I also load the private key, which we will use in order to create a wallet. I also load, I set up the environment. As you can see, there are just 4 lines of codes, and it's really easy to do that. And what we're going to do now is to create a wallet. Okay. We have 2 different wallets in Hermez Network. There is one wallet is the standard wallet, and there is another one which is the internal wallet. Okay, the standard wallet uses Ethereum address and baby jab address. Ethereum address is for layer 1, and baby jab address is for layer 2. And the internal wallet, it does only have baby jab. I'm not going into the details here because the common wallet to use will be the standard one, which is which uses Ethereum address and baby jab address. Okay. As you can see here, which data do we need in order to create a wallet? So in our case, we built what we call it a signer, because in Ethers you also work with signers, and we could use the same word here, because the signer is the type of wallet that you are going to load. Since Hermez.js is used also on front-end side, on web apps, you can load signers from private key, or you can load signers from providers such as MetaMask, Ledger, and so on. In that case, when we do a script, or we perform a script, the common use case is to load the wallet with the private key. In our case, we are going to load the wallet with our Ethereum private key, okay? And we build that signer object. Okay? So Hermez.js provides a method, which is inside the section of Hermez wallet, which is create wallet from Ether account. And then we need to provide the Ethereum node URL and the signer, which contains the private key. Just with that, we create the Hermez wallet. Okay, we create from the Ethereum private key, we create the baby jab private key internally, and then this wallet could sign message in layer 2 with the baby jab. Of course, the wallet does this for you. You can check the code internally. I will show you if you are interested. Okay, create wallet from Ether account. You will just sign a message. Here is the code how to derive the baby jab private key from the Ethereum private key. If you're interested, please ask questions about it. I'm not going into the details here, but this is important to notice. And here we are creating the wallet from Ether. This will return you the Hermez Ethereum address and the Hermez wallet indeed. So we are taking here the Hermez wallet itself. And what we're going to do now is to check all the variables that are inside. When I say variables, I mean all the properties that are inside the Hermez wallet. Of course, there is a property which is inside the Hermez wallet, which is the private key. And I'm not going to show that because otherwise you will have my private key. And okay, let's see what is printed here. Nothing is printed. Okay. Then we created the Hermez wallet. And here we can see different properties of the wallet. Okay, as you can see the public key in different formats. Okay, this is the raw public key, and when we say public key, we refer to the baby jab key, which is the key used for layer 2 transactions. And this format here is just the baby jab elliptic curve point. In its raw, this is expressed in x coordinate and y coordinate. This is expressed in its compressed way. This is expressed in hexadecimal and in base 64. And the last property that I wanted to show is the Hermez Ethereum address. As you can see, the Hermez Ethereum address is your Ethereum address prefixed by ETH in order to differentiate with the Ethereum address. And as you can see, from user perspective, we will use the baby jab coded in base 64 encoding. Okay, this is done in order to differentiate baby jab from Ethereum address. Okay. Okay. We have just created a wallet from Ethereum account. This method to create wallet is the same method used in our web app. Okay, exactly the same. And the very last thing to do in this script of creating a wallet, what we are going to do is to create an account authorization. Okay, I'm going to explain why this is important. Well, first, okay. To check here. Okay. In order, there is different ways to create an account. Okay, we already have our wallet, but in order to create an account inside the rollup, there is 2 ways in order to do that. The first one is to perform a deposit, and we will do that afterwards. And the second one is to receive some transfer in layer 2. Okay, if you are the receiver of some transfer inside the Hermez network, an account will be created for you. Okay, so in order to do that, okay, in order the coordinator could create a wallet, an account for you, and in order to do that, we need to create a message, okay, and send it to the coordinator. Okay, let me check just one thing. Okay, sorry. And here I'm going to run this script again and see that the coordinator doesn't have our message of for creating an account. Okay, as you can see here, there is no account message for our Hermez Ethereum address. So what we're going to do is now to create this account authorization message and send it to the coordinator. Okay, in order to do that, I'm going to explain these lines of code. In order to do that, we're going to create this account authorization message, which is a signature. Okay, and then we're going to send through HTTP this signature to the coordinator. Okay, through this method, post create account authorization. Okay, this method needs your Hermez Ethereum address, your baby jab public key, and of course the signature. Okay, so we're going to send this message to the coordinator, and this message, the utility of this message is to, when you receive some tokens in Hermez and you don't have already an account, this account will be created for you. So let's run the script and see if the message has been sent well to the coordinator. As we can see here, status okay, status text okay. Okay, so let's check. Let's check if this message has been sent well. Let's run the script again, and then when we call this get create authorization, which is asking mainly the coordinator if it has already the message, well, the answer now the coordinator will have the message, as we can see here. For the ETH, for this Hermez Ethereum address, has already an account authorization. Perfect. So let's move forward to the next action, which will be the deposit. This is an important one, of course. The deposit will create an account for you in the rollup. Okay. In order to do that, I'm going to, again, copy paste some previous code that I did, just in order to save time. Here, basically, with this just 10 lines of code, I have just set up the environment, and I have just created the Hermez wallet. Okay, so these 10 lines of code are the summary of the set environment and create wallet scripts. Okay. Here, we are going to load more environment variables, which are the token symbol and the amount deposit. And the first thing that I want to show now is, because at the very beginning I said there could be some tokens inside Hermez. So what we're going to see here is to get some information from the coordinator in order to see which tokens are available on Hermez. Okay, and in order to do that, I just query the coordinator with the get tokens function, and then here I will get all the tokens that are available inside Hermez. Okay, we can see here. Okay, there is a list of tokens. The first one is Ether with their symbol, decimals, USD value, Hermez token, Compound USDT, Tether, DAI, Uniswap, Chainlink. Of course, this is Rinkeby, but in mainnet, we have more tokens in order that you can create an account for those tokens inside Hermez Network. And just to clean up a little bit the code, I have just all these tokens. I have just filtered these tokens to match the token symbol that we have set it up in the environment. Okay, so finally we just have the token information regarding the token symbol that we want. In that case, would be Ether. Let's run the script to see if it works properly. If it displays just only the Ether informations, perfect. And the question now is which data we are missing in order to perform a deposit. And of course, that data, one of the most important data to perform a deposit is the amount, how much we are going to deposit into Hermez. And this amount has some particularity, which is that we use our own code and code format, okay? And we call it this format Hermez compressed amount, okay? Again, you can check the Hermez compressed amount code inside Hermez.js. We are not going into the details here, but basically it has a fixed bit size format, which is 40 bits. It's based on the standard floating point code and code, but with a little bit changes over there. the question is why we use our own format is because it's 40 bits. And as you may know, on the crypto space, most of the token has 18 decimals. So in order, how many bits do you need in order to code a really large begin? So you probably need maybe 60, 70, 80 bits. So in that case, we save a lot of space and we save a lot of data. Okay, in order to do that, it's really easy. Just in Hermez, inside Hermez.js, we have prepared some functions in order to do this encode and code of the amount. But what I'm going to do here is just convert the amount deposit, okay, which is a string. Basically, it's just a string. And I will add the decimals of the token. In that case, is Ether, which is 18 decimals. We're going to see here, for the sake of clarity, I will put it in native. And we're going to also show how the amount compressed looks like. Okay. Okay, you can see that the quantity that we want to deposit on Hermez will be exactly this, 0.042 Ether. And his equivalent in Hermez compressed amount will be, well, this value here. Okay, I will remove those consoles. Okay, and the last thing to do, of course, would be to perform a deposit. Okay, we have all the necessary data in order to perform a deposit, so we are going to perform one. In order to do that, Hermez.js provides just a transaction section which has a deposit. And basically, the data that we need to provide, okay, is the how much are we going to deposit into Hermez, which is our Hermez Ethereum address, the token information. As you can see here, this is the baby jab compressed in hexadecimal, because we only use the hexadecimal baby jab to interact with the smart contract, because it's cheapest, because we don't need to convert to base 64 inside Solidity. And of course, we need to provide the signer, which contains the private key. Okay. I want to put focus that the deposit is an interaction with the Hermez smart contract. Okay, that's why we need the signer. That's why we need the Ethereum private key. Okay, behind Hermez.js, we use the library Ethers. It's a very well-known library in the Ethereum ecosystem, and this library, when you perform some transaction to the smart contract, it returns you the transaction object, we can say, which contains the transaction hash. And in order to wait for the transaction to be mined, we can use the wait function here, and then we will get the receipt. So let's execute and let's perform a deposit in Hermez. Of course, it will take a little bit, because the transaction needs to be mined on Ethereum. I guess that in Rinkeby, it will be mined quite soon. Well, okay, it's already mined, but because we have the transaction received over there. And you may wonder that, okay, this is beautiful, but in mainnet, you need more things to do. Because you need to take care of gas limits and gas prices. So I will show you very briefly how this deposit looks like. Okay, there are optional parameters inside the deposit function. Okay, that I didn't use it here because we are in Rinkeby. But if you are in mainnet, you may want to set up your own gas limit and your own gas multiplier. Okay, that's very important when working on mainnet. Okay, gas multiplier, means a multiplier of the standard gas price. Okay. So if you want to accelerate your transaction, you will set up a gas multiplier of 2, maybe 3. If you want to use the standard gas price, you will set up gas multiplier 1. If you want a very low, to use a very low gas price, you will set up at 0.5, for example. Okay, perfect. So we have just performed a deposit into Rollup. And the deposit will create an account in the Rollup for us. Okay. In order, once you perform the deposit, which is an Ethereum transaction, until this deposit is processed and account is created for you, you need to wait a few minutes. Okay. Why is that? Because the coordinator needs to forge batches in order to create your account. Okay. I have done this same deposit yesterday with another account. So I will switch now because we don't want to wait here a lot of time. So I will switch to an account that I already have an account deposit created inside the Rollup in order to move forward for the transfer. Okay. In order to perform a transfer, of course, you need an account created on the Rollup. And this is what we are going to do right now. As I did in the deposit script, I'm going to copy paste the code that we use in the deposit script as well. Okay, just load environment variables, set up environment provider, and create wallet. Perfect. So one thing that is important to mention, for layer 2 transactions, okay, Hermez provides an ability to track these transactions in what we call a transaction pool. Okay, so from the client perspective, from the user's perspective, we have a transaction pool locally, which is the transaction that you have performed, which are the transactions that have already been processed, which are the pending ones. And this is mainly to set up the nonce of the transactions automatically. Okay, if you don't want to care about the nonce when performing a layer 2 transaction, you just have to initialize the transaction pool, and that's it. You don't need to do anything else. Just to give you an example, like MetaMask handle this nonce for you. Okay, you perform a transaction, the transaction is pending, and if you perform another transaction, the second transaction will have nonce incremented by 1. Okay, this is a logic inside the MetaMask. So this kind of logic we implemented as well in Hermez. We provide this ability, and in order to use it, you need to initialize the transaction pool first. Okay, I will just copy paste again because the code is almost the same as we used previously in the deposit. Here, we just set up again the token to be transferred and set up the amount to be transferred between accounts. Okay, and what we are going to do now. As I mentioned previously, in order to perform a layer 2 transaction, you need to know which account do you have inside the Rollup. Okay, so what I'm going to show here is how to retrieve that data, because you may know your Ethereum address, and that's it, but you may not know your account internally in the Rollup. So in order to retrieve those information, it's simple as that. Just ask the coordinator, okay, about which accounts does this Ethereum address has. okay? And let's print that information. Transfer. Okay. As we can see here, as I mentioned previously, this is an account that I made some deposits yesterday. And there is one field, important field here, which is the account index. Okay. This account index is the account that identifies you uniquely inside the rollup. Okay. And this account index is ETH, Ethereum, and this number. Okay. It is 3069. Perfect. So it's very important because one Ethereum address could have a lot of accounts, okay? One Ethereum address could have an account in Ether, which is the account that I have here. But also, I could have another account with Uni, with Hermez, with USDT, and so on, okay? So what I'm going to do now is, again, just for clarity, to filter those accounts into the one that we are going to use, which is the account with Ether. Okay. And I'm going to show the information as well. Perfect. Okay. We just filter all the accounts into the one that we want by the token symbol. Then the question now is, which data do we need in order to perform a layer 2 transaction? So basically, not just in Hermez Network, in probably in all the blockchains, you just need the sender from the receiver to the amount that you want to send and the fee that you want to send. Okay. So here we have the from, which I will take from the account information. Here we have the receiver, okay, which is an Ethereum address, our Hermez Ethereum address, okay, that I set up in the environment files. We already have the amount compressed in order to be sent. So the missing variable here is the fee, okay? And what we're going to do is to compute the fee that we're going to use. In order to do that, we're going to ask the coordinator which fee is the recommended fee. Okay, as it works with the Ethereum, if you put a very low fee, your transaction, okay, will last a lot of minutes in order to be mined. And if you put $1,000, your transaction will be mined instantly. In Hermez Network, it happens the same. Okay. But we're lucky because we can ask the coordinator which is the recommended fee. Okay. And here I'm just computing the fee in Ethereum. How much Ethereum do we need in order to send the L2 transactions? And I'm going to execute that in order to see how many fee do I need to pay. Okay. In that case, the necessary fee in order to send a transaction into the coordinator and be processed almost instantly will be 0.00014 and so on. So we have the last missing parameter here. So what we're going to do now is to generate and send a layer 2 transaction. Okay. And as I mentioned previously, this which fields do we need in order to perform these transactions is the from, is the account index that I mentioned previously, which will be the receiver, which is the parameter that I set up in the environment file, the amount, and the fee. And that's it. Okay, this is a very simple layer 2 transaction. Of course, there are more complex fields inside a layer 2 transaction, but the most simple transaction will be this one. And here we are just sending the transaction to the coordinator, and we just pass the transaction object. We need to provide the Hermez wallet because this transaction is in layer 2, so we need to sign it with the baby jab private key, which is inside the Hermez wallet, and the token information. And okay, let's send the transaction to the coordinator and see the response. Okay, so the transaction has been sent correctly to the coordinator. The transaction is in the coordinator pool. The coordinator sends us that he has received the transaction correctly. And here it's important to notice this ID, okay, here, which is the transaction ID. Okay, it's similar to the transaction hash in Ethereum. Okay? I mean, you can take this transaction ID, go to the batch explorer that we have for testnet, and check it over there how the transaction is going. Okay, if it's pending, if it's forging, and so on. And that would be all. That would be the 4 steps to use Hermez.js. If there are more utilities and capabilities of Hermez.js, this is just a very basic usage of Hermez.js. If you have any question, please ask at the end of this workshop, or we are in Discord. You can ask over there. And now I'm going to stop to my presentation, my workshop, and then Jeff will continue to some examples. But rather of using JavaScript and Hermez.js, he will use Go language in order to perform those examples. Thank you.
Thank you very much, Carlos, for all the explanations. I think Carlos was excellent, did an excellent job explaining all details, all the steps for how to use Hermez. However, before to get started with Go, I would like to ask to the attendees, except from Mario and others, my teammate from Hermez, is there any Go developer in the audience? If you could say a message in our chat, just to know all other attendees are JavaScript developers. Torsten just started with Golang. Okay, I think only Torsten is the okay. Oh, great. Okay, so Thursday I will be happy, to show an example we have created. I'm gonna share my screen. Just a second, see how I do this. Share screen. Okay. Could you say if you are able to see my screen?
Yes.
Thank you, Carlos. So I'm gonna write down here the example I just published in my GitHub. I go. So you guys can see the code I've created. Some examples is here because in order to save time, I have created the script and published in GitHub. This way, any one of you, not only Torsten but other developers can go there and see some examples. I dare to call it an SDK, but to be honest, to all of you, this is not an SDK yet. Actually, is a collection of examples, right? And as I have participated of several hackathons before, what I did here is an example that you can, very dirty hackathon style code, just to have because in general hackathon we don't have much time to code, so we get things done. So that's why you're gonna see here that basically, as the protocol is the same, is much in terms of the process is much closer to what Carlos have explained it. So the first you need to also Carlos has shared his example in our chat here. So I will, maybe the screen is recorded, so I'm gonna share the Carlos code as well. Oh my goodness, a lot of screen here. Okay, there we go. So Carlos code is here. So later I will good example. Great, Carlos. So later I will create a 0x hack, maybe dash go. Maybe I will put the published here to our examples. So anyway, you that are JavaScript developer, you can use the Carlos examples. But if you are Go developer, you can use here some examples in this GitHub repository. Basically, what you should do, first of all, you need to have okay. So first you need to connect to Hermez smart contracts here in Go. So what do we use? I create an example like a Hermez client. In this Hermez client, you include here your custom Ethereum client. So Carlos has using Fura, but I have my own Ethereum node. But here you can put your Infura credentials, you define here. Then using Geth, so Go Ethereum client that you can find here is official Go client. So we use the same library of Go Ethereum. Then we start, and also here is hard coded, but you can get from the Carlos example the Ethereum address of Hermez contract, okay, the Hermez rollup contract. So you can get the information from here. You get the coordinators addresses that Carlos have mentioned in his presentation. So. And here I also added a HTTP client to this Hermez client. Then we can use in our example here. So now we know what is the coordinator. We can send the transactions, and also we are connected to Hermez contracts. Here, so you see here is a method that you can get the boot coordinator and other information. Then we start here, and the part that we need to create or at least get the accounts data. So as Carlos have mentioned it, so using the same library that Go Ethereum use. You put your private key, you generate from the private key your Ethereum public key and your Ethereum address. And from it, here you can have the message that you need to sign here in line 82 in order to what? In order to create your baby jab private key. as we can see here. So here I have opened the box. In the JavaScript, as Carlos have shown, these steps are encapsulated. So here in Go, I just open it up. So of course you can encapsulate in a method to do it for you. Just I will have opened it here just to know the details, how to create, how is an Hermes account is created. So after you have your private key, then you can this function here generates a baby jab account for you, as Carlos has shown. So there are a few steps you can you do in order to compress and later encode the account name in base 64 format in order to be used by the users. And here is the S prefix that differentiated the Hermes account from a standard Ethereum account or any other blockchain. Okay, so getting back here. And with that, we have here a step that gets from the coordinator, you get your account information. So as I already have the Ethereum account, the Ethereum public account, you can call this method account get account info. What it does is basically what Carlos have mentioned. It goes to this endpoint and queries the account. So, for instance, if you want to know all the details of our API, you can visit api.doc.hermes.network. You can see here a very detailed Hermes Network API. So here you have a very good explanation how to call what information you're going to receive from our endpoints. Okay. So with this, after get the account information, you can see here a code that you can get compare if the address you have locally is the same of the address that you get from the server. And here we create our baby Jab wallet as Carlos have described it in a few minutes ago. So you have the baby Jab private key, your public key, your baby Jab address, and also your Ethereum address. Then now this section we go to the part of the token transfers. So in matter of time, I will skip the part from create account. So in this example, the Hermes accounts are already created. Okay, so in order to process the L2 transfers, so we create a variable here, say which item do you want to transfer. So I want to transfer Hermes tokens. So when I pull the account information from the coordinator, it gave me details from Hermes account. So I can have several Hermes accounts. So one account for Hermes tokens, another for Ether, another for USDC, for example. So in this four, we get the account details specifically for the Hermes token account. Just a matter of understanding, just to know what I'm talking about. So here I have an example. So you can see here, you have the account is, for instance, is an array. So I have two account details, one for Hermes, another one for Ether. So in this specifically piece of code, I get the account details from the account for Hermes. They I define the account index, the account number of my recipient. I define the amount is in Go is just a big int. I fill up this pool L2 struct that is the same struct that we use in Hermes node in our coordinator software. So this is the destination, the recipient account in Ethereum format. This is the part that I use Poseidon. I signed the transaction. So I use the baby jab private key and signed the transaction. I include the signature in the request. And here I generated the JSON file. And here you can see I add the actual coordinator. So this I create a URL that I'm going to post the transaction. So here is just another. Here's another HTTP post request method in Go. So for you, if you are a Go user, you're very familiar with this section. Nothing new here. Then you get the receipt of the transaction. So let's try to run this. Of course, wish me luck because as is any demo, so we need the luck to see if it runs. In just a matter of to help you that you're going to receive, I included a lot of logs, to be clear what the example is doing step by step. Okay, so this is the good part. You see, the item already existed because I already sent this transaction before to this person with the same signature. So let's change here the value. I'm gonna put another number here, 9. Okay, I'm gonna save it. Let's run it again. So why it takes a little bit? Because it's connecting to the Ethereum network. In this case, I'm going to use in my case is going Goerli, the Ethereum test network. So from it to get the data from the smart contract. From the smart contract, I go to the coordinator. So that's why it takes a little bit longer. So let's see. This is the transaction ID, and as we can see here, let me add it here. Okay, we can pull the information from our transaction pool. So we have here transaction pool endpoint. I paste here, so I can see here the details of the transaction that is waiting for it to be forged in our network. So as we are running out of time, so I would like to thank you for watching our presentation, and I would like to open for questions. Thank you very much. So maybe Torsten or any other attendee, if you want to ask a question in our chat, feel free to do so. Okay, so I think Carlos have done a very good job, gave a very good explanation. So no questions. I think everything is clear. Of course, Carlos, I are now and other Hermes team members we are in a Discord channel in Hermes the event channel, and there's a group called Hermez. So you can, anytime you want, you can write a message over there and ask us questions.
Yeah, thanks a lot, guys, for the workshop. And as Jeff mentioned, we'll be hanging out at Discord, and we can answer any questions that you might have. Most of the people will probably watch this recording on YouTube. So if you have any questions, you'll find the link in the descriptions to our Discord, where we'll be waiting for you. Thanks a lot, Jeff. Thanks a lot, Carlos. And yeah, we'll see you on Discord.
See you there. Bye-bye.
See you. Thank you all. Bye-bye.